So the last technique I'll be discussing is particle image velocimetry. This is used by Professor uh, Syed Hagazadeh in our university, and also I think by Dr. Lang. This is really state of the art in terms of flow visualization and getting velocity measurements. So what do? You put, again, very small particles into the flow, just as we would do with laser Doppler velocimetry, and you still use a laser sheet, and you illuminate an entire sheet of the flow with a laser in a thin layer. That's why it's called a laser sheet. And then you take a picture of it. But you take a picture really fast. So you take one picture and you almost immediately take a second picture. So you have all these little particles that are in the flow field, and they are all imaged by the laser illuminating them only in the plane where the laser sheet is. And you take two pictures in rapid succession, and this particle, moves a little bit, and this one moves a little bit too, and they all move a little bit. Maybe some of them don't move because they're not moving, but all the ones that are moving have moved a little bit. Some of them will have kind of left the sheet, and some of them will have entered the sheet, but a lot of them will not have moved because the time is so short. And then you use a computer to do, digital signal analysis on this image processing analysis, and you figure out, and it can track like which particle is which and what velocity it's moving based on how fast, how far it moves between those two very rapid camera images. This has huge advantages over laser Doppler velocimetry because you're measuring all these velocities at the same time, whereas laser Doppler velocimetry, you really have to point the laser at a particular point in the flow, measure the velocity at that point extremely accurately. But this, we're getting the whole field of the flow measured in one image. We can add a second camera to catch the 3D effects. This is stereoscopic imaging. This is exactly how your eyeballs work. By having two cameras, you can pick up the three-dimensional effects, and they use sophisticated computer imaging software to analyze the results to get the actual 3D velocities. Of course, you can move the laser sheet around to different points in the flow to pick up different velocities at different planes. So this is really state of the art, and this didn't become possible until these cameras got really good. So this was invented, I don't know, maybe 10 or 20 years ago. And the cameras were extremely expensive, the cameras that could do this kind of imaging, tens of thousands of dollars per camera, maybe more. And, camera prices have just gone down. Digital cameras are, as you know, are not very expensive. So these cameras are still expensive. I mean, these have to be extremely high resolution cameras, and they have to be extremely fast. So they're not cheap, but they're a lot cheaper than they were. And of course, lasers also have gotten cheaper to produce. So this is a technology that requires high-speed camera imaging, high-speed computers to do the image analysis, and that's something that just simply didn't exist in the past. So this is a new technique that is really, I believe, state of the art right now. The kind that you pretty much want to do. It doesn't have there's no invasiveness to this at all. You have these tiny, neutrally buoyant particles in the flow. They don't change the flow at all, and you can pick up complete 3D velocity imaging, very rapidly for the entire flow field. So particle image velocimetry is, as far as I'm aware, the state of the art of velocity imaging in fluids at this time. One thing you really still do need, though, is you need a fluid that's transparent, right? So you can't shoot a laser through something that's opaque. So we still don't have a great technique to measure velocities if you can't see through the fluid. So of course we're taking pictures. That implies that you can take a picture of something inside the fluid. For water, that's not really a problem. For air, it's certainly not a problem. But you can certainly imagine that there are fluids that you can't see into, either because they're simply just opaque or they're full of particulate matter or something. So that's not always possible. So this is a great technique. There are still limitations. There are still times when the way you have to go is still to just stick something in that flow and measure directly, because you can't see inside. And if you can't see inside it, then you can't do either laser Doppler velocimetry or particle image velocimetry, because you can't get the light in there or get the light out, then you can't do it at all.